Hello, my name is Santiago, and today I'll be speaking about reinforcement learning from human feedback. The name of this talk is The Cherry on the Top, and it's the story of how we built this little guy here, RLHF. Before we had reinforcement learning from human feedback, we were training large language models with large unlabeled datasets from all over the internet. We are still doing that, but we were mainly only fine-tuning these models on smaller labeled datasets to perform tasks like summarization, question answering, etc. But we were lacking a way to introduce feedback or instructions to these LLMs to get responses on a more friendly human way. This is where reinforcement learning from human feedback emerged as a potential solution because it allows us to provide instructions on how we want the LLM to respond. Here are the two main ingredients that we need to do reinforcement learning with human feedback. One, reinforcement learning, and the other, human feedback. We probably know what reinforcement learning and human feedback mean independently. Reinforcement learning is a type of machine learning method where an agent learns to make decisions by interacting with their environment. And human feedback refers to the process where humans provide input or evaluations to help improve a model. Think of giving a thumbs up when we like something or agree on something, and thumbs down otherwise. What happens when we combine these two elements with an LM and we put everything together on a ball? We get an improved and shiny LM that produces high quality outputs and ideally are aligned with human users' intentions. What do we need to achieve RLHF? Well, I like to cook, so let's turn this into a cooking analogy, and here are the ingredients that we need. We need one extra big LLM, several label examples. This is going to be useful for when we fine-tune the model in a supervised learning fashion. We also need many human ranked responses. This is where the human feedback comes into play. We also gonna need one reward model. This is where the reinforcement learning comes into play. And the magic, a pinch of PPO, which is short from proximal policy optimization. And it is the algorithm that is gonna make everything possible. Now that we have the ingredients, what do? Do we put everything together and hope for the best? Well, actually no, there's a recipe that we can follow. Here's the recipe. The step 0 would be to get access to a pre-trained LLM. Let's think of a pre-trained LLM as this huge monster that was pre-trained on an unsupervised learning fashion and saw lots of things all over the internet, from nice things to not so nice things, and basically learned how to write, in the sense that given a context and the previous tokens, it's able to predict the next word, the next token. At this stage, that's everything, that's all it can do. The idea is to turn these huge monsters into something more manageable and more beautiful. The next step is to teach it to perform specific tasks. We can do this by fine-tuning it with some demonstration data, which is a labeled data set containing information about a specific task. This could be question answering, translation, and so on. By doing this, we transform this raw, ugly model into something that is starting to look a little bit nicer. In the next step is where things start to look a bit interesting. Here we need to collect human feedback data and train a reward model. The human feedback data, often called comparison data, can be obtained by sampling multiple responses from the fine-tuned model for a set of predefined prompts. Once we have those responses, we can ask humans to rank them from best to worst. And the idea is to use this comparison dataset built by humans to train a reward model that is able to set scores from the LLM's responses. Finally, in the last step, here's where we fine-tune the LLM by using PPO, which is short from proximal policy optimization. Here we optimize the LLM to generate responses for which the reward model will give high scores. And that's how we went from this ugly, very ugly thing to this manageable thing to this little cute guy that's the cherry on the top. Here are some great references that explain the internal workings of RLHF in a very friendly way. But before going home, let's take a look at the practical code example. I call it tiny RLHF example, not because it is particularly small, but because it is the smallest example that I could think of that has an end-to-end overview on all of these steps. Also tiny because it's able to run on a free instance of Google Cloud. We'll be using basically lots of libraries from the Hugging Face ecosystem. We'll be using the Transformers library, Datasets library, the relatively new library called TRL, which means Transformers Reinforcement Learning. And yeah, the first step is to get a pre-trained LLM. For this case, I went with Flan T5 small. You could use any other one. I went with the smallest one to be able to run it on a free instance of Google Cloud. Next, we perform supervised fine-tuning. For this, we need a dataset, a labeled dataset. I'm using the Quora question-answer dataset. Bear in mind that I'm just using 100 samples. Why? Because the idea was not to build something huge, just something small that runs all the end-to-end process. So I have 80 examples on the train set, 20 on the test set. After that, we need to preprocess the data to get it in the right format for Flan T5, some evaluation metric, and then here's the core part. Here we are using the trainer from TRL to basically do the supervised fine-tuning and returns us a model that is on the required shape for later perform PPO. The second step, and one of the most important ones, is training a reward model. For this, you can do two things. One, build your own human feedback dataset. For this, as explained in the theoretical part, you can get some prompts, sample, generate some examples from your SFT model, and basically then save that, rank them, and put like which ones are good, which ones are bad, and use to train the reward model. The other option in every TV cooking show is to take an already made dish and show it to the audience. So in this case, we will be using an already annotated dataset, and a dataset that has been annotated by Anthropic, and it is a dataset that works well with reinforcement learning from human feedback. So I'm loading this dataset. We need to preprocess it in a way that it's friendly for the reward trainer, again from the TRL library. So we do that, we create an instance of the reward trainer, we add some configs, and we train our reward model. And the last step is to fine-tune the model with PPO. For this, I'm gonna load again my previously fine-tuned model. I'm gonna load it twice. One I'm gonna call it model, and the other one is gonna be model graph. This one is the one that we're gonna fine-tune by PPO, and this one is gonna be the reference. I'm gonna load again the reward model that we just created. Dataset created by Hugging Face with some prompts to help us train the PPO, to help us run the PPO trainer. And then again, we're gonna use the TRL library, create an instance of the PPO trainer, and with some arguments, perform the training loop with PPO. This is a part where we're gonna get a response from the SFT model. This means the supervised fine-tune model. We're gonna compute the reward score from the reward model, and we are gonna run the PPO optimization step. Once we do that, for each of the prompts that we have, we can save the PPO trainer, we can save the PPO model, and that's it. We end up with a model that was fine-tuned via reinforcement learning with human feedback. I hope you enjoyed it, and this link is public, so feel free to check out.